2. So chapter 2 will be tested for your upcoming continual assessment. Okay? Chapter 1, not much issue. So let's start with revision. On page 37, the factorization method. Let's just do try it one. Okay? We will not spend too much time over here. Solve 2x squared plus 9x minus 5 equals to 0. Okay, how long do you think you need to do this? Two minutes? Okay, you have 2 minutes until 1:31. Okay, try this now in your textbook. Hey, where's your frame? I want to see this. Okay. Okay, you should have at least 2 ways to do it. Where's your textbook? Huh? Then what should you have done? You could have borrowed from your classmate, right? Your schoolmate. Time is almost up. Have you factorized it already? Okay, I see many correct answers, but I see some people stopped at factorizing. You're told to solve it, not just factorize. Done? Okay, let's check our work. So I am going to use this method. 2x, x. Here I am supposed to have 2x squared. I am expecting to get 9x over here and negative 5. Okay, so factors of 5, I've got 1 and 5. What happens if I put 1 and 5 over here? So I have x. When I take x times 1, I have 10x at the bottom. What I really want is 9x. Okay, so what do you think I should do to the x and the 10x? Which one has a negative sign? Okay, there should be a negative sign over here. Therefore, there will be a negative 1 over here, isn't it? Okay, so now I have factorized it. Didn't take too much effort. 2x minus 1, x plus 5 equals to 0. This is called factorizing. Am I solving yet? Okay, something multiplied by something gives me 0. What does that imply? One of them is 0. Okay, so this tells me that 2x minus 1 equals to 0 or x plus 5 equals to 0. Therefore, x equals to half or x equals to negative 5. Right? Okay, if you use a multiplication frame, you should still arrive at the same answer. This step is just working. It's not necessary. This step is necessary. It is important. Okay? So, I now want you to try it 3. Solve the equation 2x multiplied by 5x plus 3 equals to 9 multiplied by 5x plus 3. Okay, solve this. Again, this time I'll give you 2 minutes. Okay, we'll stop at 1:35. Try 3 at the bottom of your page. Here's your close bracket. Do you need a time extension? Yes. Yeah, I give you another 2 minutes. Okay, we'll start at 37. Yes? Let me see. So what do you observe?
This one equal, this one cancel.
Uh-huh.
2x equals to x.
Okay, so what's your answer for x?
X equals 4 power.
How many answers do you have?
1.
Only one answer.
Yeah.
Okay, I don't see anything wrong with this, but could x be also equals to negative 3 over 5?
3 over 5.
Yeah. Could it be? You see, your answer over here by observation is 4.5, right?
Yeah.
If x is equals to negative 3 over 5, do you think it will satisfy the equation?
No.
Why not?
2.
Then you still got a 5x plus 3, right?
Yeah.
So what would that give you? Negative 3 over 5. Okay, you've got 1 more minute. Yeah, continue, then plus 3. 5 times negative 3 over 5. Okay, then add 3. 3 to this. Equals to negative 3 over 5. When x is equals to negative 3 over 5, what will we have over here? You have negative 3.
Yeah.
Right? Negative 3 plus 3 is 0. Okay, this times this will be 0, right? What about on this side? Negative 3 over 5. 0. 0 equals 0. So is this a possible answer?
Yes.
Yes, it is. Did your working produce this answer?
No.
No. So your working is incomplete. All right, let's begin. I see a couple of ways, a couple of different approaches that you had. Okay, now let me show you my working. All, please look at the screen. Show you something very important. How about I do this? Then I have 2x equals to 9 and x equals to 9 over 2. How about this? You look amazed. So is this correct or wrong? Huh? Wait. What's wrong with this? Nothing is wrong. Nothing is wrong. Okay. So that's it. Nothing is wrong. You're happy with this? Okay.
There's a catch somewhere.
Yeah, there's a catch. What's the catch? I heard that many of you say there should be 2 answers, right? And over here, I obviously only have 1 answer. So this is incomplete. Anyway, what have I done by cancelling like this? What exactly am I doing? Okay, I'm dividing. I'm dividing both sides by 5x plus 3. Anything wrong with that? Nothing wrong? Okay, let's see another approach. Let's take a look at another approach, which I believe most of you tried doing it this way. So you have 2x, 5x plus 3, then minus 9, 5x plus 3. Okay, so you subtracted 9 times 5x plus 3, minus 3 on both sides. And you realize that there is a common factor. Right, Darius? Right? Yes, common factor, 5x plus 3. What is left for the first term? 2x minus 9. Okay, so this must be equal to 0, isn't it?
Yeah.
Therefore, what is our conclusion? 5x plus 3 equals to? 0. or
2x plus minus 9 equals 0.
okay, or 2x minus 9 equals 0. Okay, so here we have x equals to negative 3 over 5 or x equals to 9 over 2. You notice that if we compare this to what I did earlier on, 2x, 5x plus 3 equals to 9, 5x plus 3. If we compare these two, so we had 2x equals to 9, x equals to 9 over 2. Look at the difference. This is partially correct, isn't it? I've got one of the answers. Hey, they are the same. But this act of cancelling, sorry? Yeah, so what exactly was I doing when I removed them? You mentioned correctly that I was dividing by 5x plus 3. What's the problem with that? Okay, looking back at this, what do we conclude over here? What do you conclude? 5x plus 3 could be equal to 0. Is that going to be a problem if I try and divide by 0?
Yes.
Yeah. In this case, we are going to lose this solution. It's lost. Okay? So the correct way would therefore be to factorize this way. Alright? You should have covered this in lower sec already. Okay, so that's all that I want to cover for 2.1, which is simply a recap. So homework for exercise 2.1, we're going to do very few questions. Question 2b and 2f. That's it. Okay, just these two because I've got more homework for 2.3. That is my focus for today's lesson. Okay? Now this one you will combine with exercise 2.3 homework. I'll let you know when it is due later on. Okay? So you'll be wondering, hey, what about topic 2.2? Yeah, we are going to be leaving that for later. Okay, we're going to be coming back to this topic 2.2 when we come to chapter 6. Alright, so let's skip this first. We shall now move on to 2.3. Okay, topic 2.3 is completing the square. Alright, ready? I need all of your attention. All of your attention. Okay. Let us try solving some simple equations. X squared equals to 9. What's x?
3.
Are you sure 3?
Negative 3. Is it 3 or negative?
Right? There are two answers. You shouldn't be telling me just 3 only. It is plus minus 3. So it's positive 3 or negative 3. Okay, let's try another one. Y squared equals to 121. What's y equals to?
11 plus minus 11.
Okay, so 11 or negative 11. You can write it this way or you can write it this way, okay? They're both fine. What if we have a squared equals to 8? What's a equals to?
8 plus root, 8 root plus minus root.
Root what? This?
Yes.
Okay, so we have two answers again, right? So it is square root 8 or negative square root 8. Okay? Difficult? Not difficult. Okay, let's try something else. X plus 4 square equals to 25. Now we have to solve for x again. What do you think the first step should be? Expand. So if I were to expand, I will get x squared plus 8x plus 16 equals to 25. Do all of you agree that we should expand? Okay, so what is your suggestion now? Square root? Square root both sides. Okay, anything wrong with this rate working?
No.
Nothing wrong. Nothing wrong with it. You'll still be able to get an answer. But how about let's just square root both sides and we see what we get. So we have x plus 4 equals to 5 or negative 5. What is x now equal to? 1 or 9. Negative 9, okay? Right? All agree? Now you see, if I chose to expand it out, I will eventually need to factorize again. And then I'll have x equals to 1 or -9. Both ways work. But I'm trying to tell you that sometimes when we have an equation like this, I want you to realize that hey, it's really easy to solve it. All we need to do is to just square root both sides. Don't you agree? Now, would you prefer to solve this one over here, or would you prefer to solve this? Left or right? Okay, very good. Okay, so let's try one more example. X minus 5 square equals to 7. Okay, what do you think we should do? Square root, and we get okay, so x must be equal to 5 plus square root 7 or okay. Very good. Now, suppose I were to expand this out, okay? Let me just do some side working from here. X squared, if I were to expand it out, I'll get x squared minus 10x plus 25 minus 7 equals to 0. Square minus 10 plus 18. Am I right? Okay. Suppose the question is to solve this. X squared minus 10x plus 18 equals to 0. How will you solve it? Factorize? Shall we try factorizing this? Okay, let me remove all these first. So now, new question. New question. I want you to solve this. X squared minus 10x plus 18 equals to 0. Factorize, come on. You learn factorizing, right? Can we factorize? X with something equals to 0. What is this over here? Can we factorize? Cannot. How do you know cannot? Because mode 3 actually tells you that you're going to get a whole string of decimals, right? That is a clue that you cannot factorize it. Then how? Use the plus minus? What do you mean? Quadratic formula. What if you are told not to use the quadratic formula? Then wouldn't it be great, class listen, wouldn't it be great if I can change this form into this form, then from this form I change it into this form, and then I get my answer x minus 5 equals to plus minus root 7. Then x equals to 5 plus minus root 7. Is this the same answer as what your calculator told you when you tried to solve for this? Okay, you get it? Wouldn't it be great if you were given this equation, there's some way for you to change it to this form, then there's some way to change it back to this form, such that I can solve for x equals to 5 plus minus square root 7. Okay, plus 7. Okay, we'll figure this out together, okay? All right, Darius? Okay, some warm-up questions. I will now give you little squares. These are squares that measure 1 cm by 1 cm. Okay, 1 cm by 1 cm. I give you 4 of these squares. Can you form a big square with this? I give you these 4 little squares. They are identical, all 1 cm by 1 cm. Can you form a big square with this? Okay, what will we measure?
2 by 2.
Okay, so we will get this. 2 cm by 2 cm, right? What's the shape of this? It's a square. Okay, what if I give you, let's say, 9 of them? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now arrange them into a square. Can you do that? Okay, obviously we are going to get 3 by 3. Okay, then you see that the area is all the same, right? Okay, what if now I give you 8 of them? 1, 2, 3, 4, 5, 6, 7, 8. I want you to form a square for me. Can you form a square? Huh? The outline? No. I'm not talking about IQ questions. Okay? I'm talking about simply piecing them together to form a big square. I don't care about one big outer square, little squares inside. No, I just want one square. That's it. Can you do it? Let's try and arrange them, okay? 1, 2, 3. Should I go down to the next row? Okay, 4, 5, 6, go down, 7, and 8. Do I have a square? No, I don't. If only I have, how many more pieces? If only I have one more piece. Okay, if only I have this. If I add one square, I would have completed the square. You get it? If I add in one small piece, I would have completed the square, right? And you'll be measuring 3 by 3. Okay, let's try another example. Huh? Oh, very tired of drawing squares. Let's say I have 13 squares. Okay, 13 little squares. I want to form a big square. Can I do that? No. Okay, what do you think we will end up with? How many on the first row? 4. Wow, how do you know? Huh? Okay, 4. Then next row, another 4. Okay, another 4. And then 1. Okay. So I don't have a square. What should I do in order to complete the square? If only I have 3 more squares, then I would have completed the square to give me 4 by 4 to get 16, isn't it? Okay, this is with numbers only. Now what does this actually mean? Okay, what does this mean to you?
X squared plus 4x plus 4.
Are you expanding?
Yeah.
Okay, yeah, you can choose to expand, but x plus 2 squared, doesn't that also mean this? X plus 2 multiplied by x plus 2? If I draw it pictorially, shouldn't it look like this? X plus 2 over here, and over here, x plus 2 as well. Agree? And if I show it this way, if I have this to be x, I don't know how much is it, okay? And over here I have 2 units. Does this still make sense? X plus 2?
Yes.
Okay, and on this side, x, and this side 2. Does it still make sense?
Yeah.
Okay, what is the area over here?
Square.
The shaded one. X square, okay, excellent. So we've got x square over here. What do we have over here? This part? 2x. This part? 2x, and the last bit? 4. This tells us that this is equals to x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4, which is how you expanded, right? Okay, so this is the pictorial representation, okay, for a perfect square like this. What happens if I didn't have a 4 over here? What happens if this is a blank? Is this a perfect square? No, it is not. What shall I do in order to complete the square? I need to add 4 in order to complete a square, and then the completed square form will look like x plus 2 square. Agree? Okay. This is some basics that we need to know first. Now, I give you another expression. X squared plus, let's say, 8x. Is this a perfect square? Is this a perfect square? Can I write this as x plus something and then square? Is this a perfect square?
No.
Yeah, I can't do that. But I would like to try to do it. Let's look at what it means pictorially. X squared plus 8x. You have x, this is x. So this is obviously x squared, right? Now 8x is simply 8 times x. Okay, let's say I have it over here. This is 8x. How much do you think this is? 8. And this must therefore be x, right? Okay, does this actually look like a square to me? To you? Does it look like a square, right? Let's compare this with this diagram. Okay, there are some similarities, but not the same. Now I'm going to try and make this into a square. What are some suggestions that you can have?
Add 1 more 8x.
Plus 1 more 8x at the bottom. Then I'll still have a missing piece, right? So I still need to plus another 64 over there, isn't it? Any other ways? I want a small square. I don't want such a big square. Okay, how about this? I try to split this into 2 equal parts. Okay? How much is this now? 4 and 4, right? Now I'm going to move this piece. I'm going to move it over here. Okay? So this is what I'll get. So this portion it will be? How much is this portion? 4. This must still be? X. Okay, so now this 8, originally 8, I'm going to split it up into 4 and 4. Okay. This is 4. Is this diagram still representing 8 squared plus 8x? Sorry, x squared plus 8x? Yes, it is still representing that. Is it a perfect square? What do you think I must add to... Oh, you guys are fast, huh? So what is the missing piece? 16. If I add in 16, what will I get? Perfect square. Okay, so now I want to add in a piece of 16, and what therefore will be a perfect square? What is your perfect square going to be? What are the dimensions? X plus 4 times x plus 4. Okay, that is if I add in 16, right? Okay, so now, can I say that this x squared plus 8x is actually equal to x squared plus 8x plus 16 because we wanted to add in the missing piece, right? 16. Can I say that they are equal? Oh, I can't. Then how do I ensure that they remain equal? I added a 16 to the right hand side, right? What do you think I should do to ensure that the left hand side is still equal to the right hand side? X plus 4 bracket square. Not yet, not yet. What do you think I should do to ensure left hand side equal to right hand side? Because as we all can tell, they are no longer equal. Plus 16 to which side? To the left hand side. But the left hand side was originally my question, right? I don't want to change my question. What should I do? Minus 16. Excellent. Minus 16. Okay? Now, are they the same? Yeah, they are equal. In addition, we have done something magical. We have done something magical. What's so magical about this? These three terms, what do they give you? A perfect square. What was the perfect square? The diagram that I erased just now? X plus 4 squared minus 16. Okay, now do you see that from the left hand side, I did not have a perfect square. After I did something, we'll go through the steps again. After I did something, I generated a perfect square, but minus 16. Right? Now, side working, because I sometimes doubt myself. Are they really the same? Let me check. Oh, have you checked already? Okay, right hand side is x plus 4 square minus 16, which gives me x squared plus 8x plus 16 minus 16, right? Oh, x squared plus 8x. Yeah, they are still the same. This is equals to my left hand side. So nothing wrong so far. Okay, I completed the square over here. Okay? So how the idea now is to generate this. How do we do it? How did I do it? It had everything to do with this diagram that I unfortunately erased. Let me bring you through the steps. Okay? For completing the square, such as this question, x squared plus 8x. If I ask you to complete the square for this, first step, I want you to check that the coefficient of x squared equals to 1. Is the coefficient of x squared equals to 1? Yes, okay. Let's move on to the second step. Half the coefficient of x. What is the coefficient of x in this case? 8. Okay, we all can tell it is positive 8. Could the coefficient of x be negative? Could it be? Yeah, it could be. So if it is negative, you still halve the negative value as well. Now the third step I want you to do is to square the half of the coefficient of x squared. Okay? And we want to add it. Add 3. Okay? After we add in the square, we are going to subtract it such that they will remain equal. Okay? Now we'll follow these steps. Okay? Now, step number 1, coefficient of x squared is 1. Let's move on to step 2. Let us half the coefficient of x. What is the coefficient of x? It is 8. We are going to halve it, and that will be 8 over 2. Okay, and we are going to square it, right? Take the coefficient of x, we're going to halve it, we're going to square it, we're going to add it. This portion over here is completing the square. We are now adding the missing piece. Remember we had a chunk of 8x. I split it into two parts, right? That is the 8 divided by 2. Then I got 4 and 4. Then I rearranged the two rectangles. Then I had a missing piece. And all of you could tell me that it is actually 16. You got 16 from 4 times 4, which is 8 over 2 times 8 over 2. This is adding in the missing piece. After I've added in the missing piece, now what do I need to do to ensure they are equal? I need to subtract it again. So minus the same thing, 8 over 2 squared. Okay? Now, the first three terms, if you can remember the diagram, gives us x plus 4. Where did the 4 come from? 8 over 2. X plus 4 squared. Minus what? 8 over 2 was 4, right? Times 2, squared, we get 16. This is the process of completing the square. Alright? Let us try it. You can look at page 49 of your textbook. Page 49, they summarized it for you. The process of making x squared plus bx into a perfect square is called completing the square. And we will add b over 2 square. And we are going to subtract away b over 2 square again. And this portion will give us x plus b over 2 square, where b is the coefficient of x. Alright? Any questions? No, then let's do examples. Let's try example 9a. Slightly different question. Let's read the question together. Express each of the following in the form x plus h square plus k, where h and k are constants. Express x squared plus 10x minus 3 into this form. Do you understand what they want you to do? Yeah, exactly. They didn't say anything about completing a square, right? What exactly do they want you to do? Now, this is what you need to know. Whenever they ask you to express, in this case, x squared plus 10x minus 3 in the form, this one, they are trying to tell you to complete the square. Okay? Because in my own example, I wanted you to complete the square for this. I changed this into this form. Do you see that x squared plus 8 is actually the same as x plus 4 square minus a constant over here? This is the form x plus h square plus k. Okay? When you see the question like this, they are trying to get you to complete the square. Alright? So completing a square. Let's just do it. First, we write down the expression x squared plus 10x minus 3. Okay? The process of completing the square. First, check that the coefficient of x squared is 1. Is the coefficient of x squared 1? I tell you a secret. For E-maths, right? All your coefficient of x squared will be 1. For E-maths, completing a square. For A-maths, may not be 1. Do you know how to make it equal to 1? Let's say my own question, okay? Let's say there's a 2 over here. Can you simply divide by 2? Factorize, yes. You should be factorizing. So this will become like this. This will be 5, and this will be negative 3 over 2, okay? So then you can complete the square over here because the coefficient of x is now, the coefficient of x squared inside this bracket is now 1. Okay? So that's the difference between A-maths and E-maths. Now back to this. Okay, x squared plus 10x minus 3. Since the coefficient of x squared is 1, I can now proceed with the next step. Okay, I'll just copy this down, x squared, then plus 10x. What else did I say? You are supposed to look at the coefficient of x. What is the coefficient of x in this case? 10. What are we supposed to do with it? Divide by 2. And what am I supposed to do with that value? Square it. And we add it, right? So plus 10 over 2. And I square it. Then I minus it away again. 10 over 2 squared. Are they now equal? Left hand side and right hand side? Look carefully. Are they equal? Left hand side and right hand side? Look carefully. Are they equal? No? Is there something extra? Yeah, there's a minus 3 over here, right? Let's put it back in. Let's not forget him. Okay? So what I have done over here is to keep this negative 3 at the end. It is not important for my process of completing the square. It is not important. It's just very extra. I just need to remember there's this guy at the end. Okay? My focus is on x squared term and my x term. So let me highlight these two parts. They are the same as this portion. Okay, the two green highlighted parts are the same. Can you all see that? Okay, now the purpose of adding 10 over 2 square is to add in the missing piece, right? Remember, we want to add in the missing corner at the bottom of the square so that we can complete the square. What does this give me now? X plus 5. Where did I get a 5 from? 10 over 2, yes. From this 10 over 2, I bring it down over here. Okay, x plus 5, and this is a perfect square. What else? What is next? Minus 3. What else? Is that all? Minus 10 over 2 square, right? Can we work out how much that is? Minus 25. Can? So I'm sure this is easy to iterate. X plus 5 square minus 28. That's the answer. Is this of the form that the question wanted? They wanted it in the form of x plus h square plus k. This is the form they wanted, right? Is this the same form? Yes. Can you tell me the value of h? 5. The value of k? Yes. Do we need to write down h equals to 5, k equals to negative 28? Yes. No need. The question asks you to express it in a form. I have expressed it in a form. They didn't ask me for the values of h and k. Okay? So don't need to do extra steps. Now it is of the form already. Yes? Why does the coefficient of x squared need to be 1? Okay, the process of completing the square just now, I started with this diagram. Remember? I had this length and this breadth to be both x, right? That is how I got x squared. If the coefficient of x squared is, let's say, 4. So this must be 4x squared, isn't it? Then this must be 2x and this must be 2x. Then this portion over here will be 2x. And this, if the question didn't change, it will still be 2. Then this value over here will now be, it will still be 4. And our completing the square process is going to be different. Because I no longer have x squared. Okay? Then, let me see. This part, the process of getting the value 4 from this question, which is simply 8 divided by 2, and then we square it, will no longer hold. Because there is a change in the coefficient of x squared. So to simplify things, we've come up with a process, in this case, which is to make sure that the coefficient of x squared is 1. And in the event that the coefficient of x squared is not 1, all we need to do is to factorize the value out. Then we do everything the same again. At the end of it all, we multiply the factor of 2 back in again. Okay? Alright, your turn to try it. Example, no example. Try it now. Try it 9, 8. Okay, try it 9, 8. Express in a form x squared minus 12x minus 5 as x plus h squared plus k. How long do you think you need? 3 minutes. Okay, you have 3 minutes. So we will end at 2:11. So if you have questions, please raise your hand. I'll come to you. you get to see me after class. Okay, remember the process, huh? We are going to check that the coefficient of x squared is 1. We are going to look at the coefficient of x, divide it by 2, square it, add it, remove it, complete the square. You just practice enough, it will all come very quickly to you. Okay, copy down the first two terms. Write down equal. Just write equal beside it. Actually, I meant this way. Okay, just write down x squared minus 12x. Okay, check. Is the coefficient of x squared 1? Is the coefficient of x squared equal to 1? Yeah, it is. Okay. What is the coefficient of x now? Coefficient of x. How do you know it is 2? Where? No, that's the power. Coefficient of x, the number just before the x, what is it? Is it positive 12 or negative 12? Negative 12. Okay, that is the value we want. Negative 12. We are going to divide it by 2. Okay, so plus, open bracket. Okay, what is it that is divided by 2 again? Okay, close it. And we're going to square it. Okay, now that I've added this in, what should I do? Make it the same, right? So I must subtract it again, okay? Write down exactly the same thing. Okay, is there anything that is missing? Yeah, okay, write it down. So I want you to bracket these first three terms. They are going to be our perfect square already. Okay, how much is that? Put down an equal again. Next line, equal. How much is that? Start with a big bracket. Okay, what do we have? X, then minus, good. What is inside this bracket? What is negative 12 divided by 2? Okay, so you wrote down the negative already. What is missing? Okay, continue. Close it, square it, then the rest do yourself. Oh, time has we've exceeded the time already. Are you all okay with this question? Yes. Yes? Who is okay with it? And you got the correct answer? Okay, for the rest of you, let's see how it is, how I want to do it.
Bracket x minus 6 power to minus 41.
Okay, due to technical issues, the following parts are not recorded. Okay, so we have to complete the square now. Check. Is the coefficient of x squared 1? Yes. Yes, it is. Okay. Next, I'm going to copy down. I'm going to copy down the first two terms, x squared minus 12x. Okay, standard. Always just copy down the x squared term and the x term. Now I'm going to add in a special number that always looks like this, right? This special number is always something over 2 and then we square it. Then we are going to subtract the same number again. And we are going to have a minus 5. Now what is the missing numerator? Is it 12 or negative 12? Or does it matter? Okay, so question, is it 12? Or is it negative 12? Or it doesn't matter? Doesn't matter. Okay, so listen up. It doesn't matter. Because we are going to square it anyway. But for, I think it is a good habit for you to put negative 12 over here. I think it is a good habit. Even if you put 12, you are okay. You won't be marked wrong. Okay? I put negative 12 to reflect that, hey, actually it was a negative number over here. Now, I am going to combine the first three terms into my perfect square. What does this give me? These first three terms? X minus 6. Okay, where do we get the negative 6 from? Yes, negative 12 divided by 2. And that is why I prefer to have a negative sign over here. Okay? So we're going to square this. And what's next? Minus how much? 41. Minus 41. Okay, so 12 divided by 2 is 6 squared, 36. Negative 36 minus 5, negative 41. Okay, yes, you're right. Okay? Now this is the process of completing the square. Next lesson, which is tomorrow, I'm going to talk about what happens if the question looks like this. X squared minus 12x minus 5 equals to 0. And then your job will be to solve this. Do you know how to solve this? How do we solve this? You mean factorize, right? Does it always work?
No.
Sometimes cannot factorize. Then how? What are we going to do if you can't factorize it? We can use our quadratic formula, which is actually in 2.4. Or we can use completing the square. Tomorrow I'll show you how to do it. Okay? So today when you go home, I want you to try it 9b. That's all. And we'll go through it tomorrow. Okay? That's all we have for this lesson. How many questions for homework do you have? The first two that I mentioned in exercise 2.1, it is not due yet. You just combine that with your exercise 2.3 homework. Otherwise, it's just going to be one piece of A4 paper with only a few lines. So don't waste paper. We'll combine with 2.3, okay? So today's homework is only try it 9b. Alright? Any questions? Okay, class 10. What lesson do you have now? Thank you, class.
Thank you, Mr. Wong, and
have a nice day. Look for your physics teacher for that.